3, start. Hello students, welcome to YouTube channel Engineering Mathematics Made Easy for All. Today we are going to study triple integral. We see the definition, formula and solve the examples. Without wasting the time, we'll go it immediately. Notes will be uploaded in the YouTube link. In the description box you'll get the link. Just click on that. The notes will be downloaded. And before going to triple integral, I have also prepared video on double integral. You can find it in the description box, students. Please watch it, practice it. Very important for the examination point of view. And please subscribe to the channel. Here we see the triple integrated integral, students. Concerning these are computed as 3 embedded integrals. Here you can see, students, this is function of x, y, z, dx. This is x2, yz, x1, yz, the upper limit and lower limit. So this is considered as always. We're going to differentiate with respect to dx. The next integration, evaluation of integration will be with respect to y. So here you can see y2z and y1z, and the last integration will remain dz, integration of z1 to z2. As with double integrals, the bonds of inner integrals might be functions of the outer variable. This bond functions are what encoded the shape of R. Yes, friends, we can see here there is a box here. We can see this is a geometrical figure of triple integration. This is x-axis, y-axis, and this is z-axis. So here we see very simple. This is a cube. Is it clear? So cube is a three-dimensional. See, this is a three-dimensional. It is a function of x, y, and z. So please remember this, students. Function of x, y, z. Here I will tell you how to evaluate the integrals, and then we discuss some of the examples. Okay, we'll start how to evaluate triple integrals. Okay, let us see how we are going to evaluate triple integral. Now, if you take this as I is equal to integration from x1 to x2, integration from y of x1, y of x2, and integration from z of x comma y, and this is z of x comma y. So let them give the function x, y, z. First we'll take dz, dy, and dx. So here you can easily see that we're going to integrate the first integral very easily. So this is z is there. In this equation, students, x, y is given, z is outside. So therefore we integrate z. This is the one reason. Next, here we can see another integral, how to evaluate triple integral, students. Next, I'm going to integrate with respect to y, because here function is given y of x2 and y of x1. The last is remaining with respect to x. So this is how we integrate, students. So some of the books, they always prefer this way. There is another way of writing this. Same way they will write it now. z1, z2, integration of y of x1, y of x2, integration of x of yz, and x of yz. Yes, friends. In such cases, you can see this is again a variable of function x, y, z. Now, in such cases, we can see first I am going to integrate with respect to dx, then I am going to integrate with respect to dy, and lastly I am going to integrate with respect to z. So this is very important to understand. I have taken x because here x we are going to substitute, y and z will be present here in this function. Then I am going to integrate this with respect to y. Here x is present, right? And then lastly I'm going to integrate with respect to z, where here z is present. It's very clear. In the first integral here z is present, here x is present, and here y and z is present. So like this, it is a combination of y and z. So in this way you can see we're going to integrate in the both the ways. So both the examples I'm going to take, students. Stay tuned till the end of the video. Very important questions I'm going to discuss examination point of view. These equations are also going to come in your GATE exam. See that you prepare very well and practice the same examples Yes students, so example 1, immediately you can take down this students. Very simple question will be asked in the examination. They are going to give you evaluate. Yes students, they will tell you only evaluate, that's it students. Then they will give you integration 0 to 1, integration 0 to square root of 1 minus x square, integration 0 to square root of 1 minus x square minus y square. So they have given here x, y, z, dz, dy and dx students. Okay, so they have given very simple. So you have to find out is remember what to substitute first. Now in this function, so first it's already rewritten. You can look at this. So easily you can find that this is already written x, y, z. So dz will be, this is the term of z. So you have to write this once again. So I will take let I is equal to, very important questions. Please see that to simplify this problem. So I'm going to take this once, integration 0 to 1, then integration 0 to square root of 1 minus x square, integration 0 to square root of 1 minus x square minus y square. Am I right? So this will become now x, y, z, dz, dy and dx. Here you can look here students, this is a function of x and y. So what is missing here? This is the trick you have to remember. What is missing? Z is missing. Yes students, so z, this is the value of z. Z is missing means you have to substitute z value. Is it clear? Same way after z, leave the z now. What is missing here? Z is already gone, so only x, y is remaining. So what is missing in this? Square root of 1 minus y square, x square. Y is missing, so this is y. So what is remaining students? X is remaining. This is how we can make out. So this is z, y and x. This is the one way to identify which value you are going to integrate. Okay, without wasting the time students, quickly simplify one by one. Okay, first I will keep 0 to 1 as it is, no change. Then next I will keep 0 to square root of 1 minus x square as it is, no change. Now we are going to integrate with respect to z. Okay, so now x, y I will keep it as it is, constant, and z I am going to integrate. Integration of z is going to become z square divided by 2 in the limit 0 to square root of 1 minus x square minus y square. So what is remaining? Dy dx. Immediately you can see as one, this is going to become 0 to 1, integration 0 to square root of 1 minus x square, x, y as it is. I will substitute first upper limit and lower limit. First I will substitute upper limit. So this is square is there, so I will just take this as 1 minus x square minus y square, the whole square. So upper limit is subtracted, lower limit is always 0. So here I am going to take 0 itself. So there is no change in the remaining terms. So here you can see square root and square will get cancelled. So only 1 minus x square minus y square is going to remain. Okay, so then I'll simplify this. Divided by 2. Please remember this ones. Divided by 2 is there. Okay, now you simplify this ones. So you are going to get in this way. So this is equal to integration 0 to 1 and 0 to square root of 1 minus x square. Then 1 upon 2 is constant. What is remaining students? X, y is remaining, and square root and root will get cancelled. So this value is going to become 1 minus x square minus y square. Yes students. So this is dy and dx. Is it clear students? So like this you have to simplify. Okay, now we'll solve the next. Just see here now. Just finding it. Okay. Fine, no problem. So this is going to be equal to integration 0 to 1. 1 upon 2 is constant, so we'll take out 1 upon 2 outside. X, y will multiply inside this bracket is going to become x, y minus 1 x square is there and this x is there. So this will be x cube y minus, here you can see students x, y square is there. I will just bring this x, y inside this. So x, y cube is okay. So this is just for our simplification I have taken this. Okay, so this is going to become 1 upon 2 integral 0 to 1 integral 0 to, now I am going to integrate with respect to y students. Okay, so then when you are going to integrate with respect to y, so please see that I am going to apply the integration here. So here our integration start, only y I am going to integrate. So x as it is, integration of y will be y square upon 2 minus x cube y square upon 2 minus x as it is Now here you can see students a y cube is there, so please remember this is going to become y cube plus 1, that is y raised to 4. So integration of y raised to cube is going to become y raised to 4 divided by 4. Now upper limit and lower limit I'm going to substitute 0 and 1 minus x square dx is remaining. Okay students, so immediately simplify. This is 1 upon 2 integral 0 to 1. First I will substitute square root of 1 minus x square wherever y is there. So upper limit I'm going to substitute x as it is. Yes friends, square root of 1 minus x square the whole square divided by 2 as it is, minus x cube by 2 as it is, and square root of 1 minus x square the whole square I'm going to substitute only y square, so minus x upon 4 as it is. Here you can see students this is raised to 4, so I say that this is square root of 1 minus x square the whole square I will take. So my simplification, okay, nothing else, because square of square is again 4 only, so there is no change. So why I have taken this square, because this 2 and this square root will get cancelled, this 2 and this square root will get cancelled, this 2 and this square root will get cancelled, therefore you will get this as, and 1 upon 2 integral 0 to 1. Here we see x 1 minus x square upon 2 minus x cube 1 minus x square upon 2 minus x. Yes notice here 1 minus x square is there, but one square is gone, another square is there, please remember here. So this is dx. Is it clear? Okay, so now just simplify this. Square root and square will go, just open the brackets. Okay, so this is going to become, this will be equal to, here another change I am going to take, I will just take out 1 upon 4 outside, 4 I will take it outside, 4 from this, 4 from this, 4 from this I will take it. So 1 upon 2 already is there, so this is 1 upon 4 I will take outside, so this will be integration 0 to 1. Here if I take out 4 divided by 2 is there, so 2 is remaining, 2x 1 minus x square minus 4, if 1 upon 4 if I take outside students, here you can see another 2 is required, so I will take this as 2 x cube 1 minus x square minus, here if I take 1 upon 4 then no change, x 1 minus x square the whole square dx is remaining. So just I have taken 1 upon 4 outside, therefore I am going to multiply and divide it by 2. So I have to multiply here 2 to make this 2 4. Is it clear? Same way here also I will multiply here 2, so that this value is going to become 4. So all three sides 4 is common, so just I have taken this 4 outside, this 4 outside and this 4 outside. Is it clear? So this is how I have taken 4 outside, so don't get confused. Okay, so next simplification students, I'm going to take the square root of a minus b the whole square, I will simplify, and this 2x I will bring inside, this 2x I will bring this side. Here I am going to apply a minus b the whole square, which is equal to a square plus b square minus 2ab. This formula I am going to use. So these three things I will do in the next step. Okay, so please write down, this is equal to, now again you can see here 1 into 2 into 4, so 1 into 2 into 1 into 1 divided by 2 into 1 divided by 4 is going to become 1 divided by 8. Okay, so this is integral 0 to 1. So 2x if I bring it inside students, what will become? It is going to become 2x minus 2x cube. Is it clear? Here also if I take minus inside, minus 2x cube plus 2x raised to 5. So already 2 is there, 3 is there, and just take it 2, it is going to get 2x raised to 5 students. Okay, then minus x. Okay, so here I am going to take x minus a minus b the whole square, so this will be 1 plus x square students, so then I am going to take x raised to 4, so b square I have taken here, this is a square plus b square. Please remember here b is x square is there, b is x square is there, so b square will become x raised to 4, then minus 2ab, so I am going to take minus 2x, so this will give you dx. So this all simplification you have to do here students. Okay, now again I will take this x inside this bracket, so this value will give you 1 upon 8 integral 0 to 1 2x minus 2x cube minus 2x cube as it is, no change, 2x raised to 5 minus, I'm just taking x inside this bracket, so you will get this as minus x raised to 5 minus into minus plus. Here please remember again, b is x square, so x square, and this x will give you 2x cube. This is very very important. This is where many students make mistakes, so I want you should not make the mistakes. So now 1 upon 8, I will integrate 0 to 1. Now here we can see 2x raised to 5 minus x raised to 5. So this is only x raised to 5. Then here we can easily see, yes friends, minus 2 x cube and plus 2x cube will get cancelled. What is remaining? Minus 2 x cube is remaining. Okay, next 2x and minus x will give you plus x. So this is what simplification we can do. Dx you will get. So this is equal to 1 upon 8. Now integrate students quickly. X raised to 6 upon 6 minus 2x raised to 4 divided by 4 plus x square divided by 2. The integral 0 to 1. Substitute in the calculator students. You will get this is 1 upon 8, 1 upon 6 minus 1 upon 2 plus 2 on the 2 to the. So this is 1 upon 2. The answer you should get 1 divided by 48. So this is how we have to simplify the problem. Yes students, quickly take down the next example. Example number 2. Please rewind the video once again and watch the video completely. Next example number 2. Evaluate integration 0 to 1. Integration 0 to square root of 1 minus x square. Integration 0 to square root of 1 minus x square minus y square. Then this is going to give you dz dy dx. Square root of 1 minus x square minus y square minus z square. Okay, this is a question they have given here students. Immediately take down the solution. Okay, so let us take the solution. Let I equal to integral 0 to 1. Okay, now first you have to simplify. So for our simplification, I want to simplify this. I remember the square root of a square minus z square. Is it clear? So I'll just take down this 1 minus x square integration 0 to square root of 1 minus x square minus y square. This is going to give you, I'll just take this here, 1 divided by square root of 1 minus x square minus y square minus z square dz dy dx. How to make out the integration students, which you have to integrate? Here you can easily see what is missing in square root of 1 minus x square minus y square. Z is missing, so this is z. It is understood. Z is gone, only x y is there. So what is missing here in the square root of 1 minus y square x square? With square root of 1 minus x square, y is missing. So this is substitution of y. What is remaining? X is remaining. So this is z value, this is y value, and this is x value. So first I am going to integrate with respect to z, then I am going to integrate with respect to y, and lastly I am going to integrate with respect to x. Just please remember this, very very important. This will change in the next example, just keep a watch. Okay, so next example you find this is a little bit different, so keep on watching the video. So continuously simplifying the example students. Here we can see, remember the formula. We know that, we remember the formula students. This is 1 divided by square root of a square minus z square d. Okay, if I take x dx is equal to sine inverse x by a. This formula you should remember students. So here I am going to substitute the same way. A. So in a square I want this term to be a square. So okay, no problem. So I will take a square is equal to square root of take a square is equal to, this is 1. So just take this as 1. Just a minute. 1 minus x square minus y square. So to simplify this, I will take a square in terms of, okay, so now you can see, yes friends, integration can be written as, this is equal to, integration will be going to be 0 to 1, integration 0 to square root of 1 minus x square, then integration 0 to, yes friends, now I have taken a square is equal to 1 minus x square minus y square. So I will just write here a square I have taken square root of a square I have taken 1 minus x square minus y square, right? So a will become square root of 1 minus x square minus y square. So instead of here square root of 1 minus x square, I'll just take it as a. That's it. That is the simplification what we have put. Okay, so now this is going to become 1 divided by square root of a square minus z square. So this is dz dy dx. Okay, no problem. Now you can see here you are going to use the formula of sine. So this is integration 0 to 1, integration 0 to square root of 1 minus x square. Yes students, this is going to give you sine inverse a divided by z divided by a in the limit, sorry, in the limit 0 to a. So now we can see as students, where is the limit? dy and dx. Okay, so let us simplify this now. Okay, wherever z is there, I'm going to put 0, and wherever z is there, I'm going to put a. So very simple, integration 0 to 1, integration 0 to 1 minus x square. Now I will put the upper limit sine inverse a divided by a minus sine inverse, this is 0 dy dx. So sine inverse, let's remember this one, sine inverse 1 a divided by a is nothing but sine inverse 1, which is equal to pi by 2. So please remember this formula. We are going to substitute this directly, and sine inverse, please remember sine inverse 0 is 0. Okay, so this is going to give you integration from 0 to 1, integration from 0 to 1 minus x square, it is pi by 2. Pi by 2 into 1, I will take this dy dx. If you want, you can take pi by 2 outside, which is a constant. So this is integration 0 to 1, integration 0 to 1 minus x square, 1 into dy dx. So integration of 1 students, please remember integration of 1. So this is pi by 2, integration 0 to 1, integration 0 to 1 minus x square. I'm going to integrate with respect to y. So this is the function of y. I'm going to substitute. Therefore, please remember integration of 1 will give you y. So this is y in the limit 0 to square root of 1 minus x square dx. Okay, so now integrate pi by 2 as it is, no change, integration of 0 to 1. So first I'll substitute 1 minus x square minus 0 dx. So now you can see I'm going to integrate 1 minus x square only. 0 is gone, so no need of writing that. So but please remember the formula. We know that. What we know that, students? Yes, we know that integration of square root of a square minus x square is equal to this will give you x square root of a square minus x square upon 2 plus a square by 2 sine inverse x by a. So this is the formula we have to remember. So I'll just substitute a square, we have taken 1 in the example, you can see. So therefore the integration is going to give you, students, pi by 2. Pi by 2 integral is going to give you x square root of 1 minus x square upon 2. Wherever a is there, just put 1 upon 2 sine inverse x upon 1 is there. So in the interval x is equal to 0 to 1. Okay, so this is the integration. Now put x is equal to 1, x is equal to 0. First I will take the upper limit x is equal to 1. Here you can see, students, square root of 1 minus x square is there, or you can see square root of 1 minus 1. If I take this is 0, this term is going to give you 0 value. So therefore this is pi by 2. I will take directly this is 0 plus 1 upon 2 sine inverse 1 minus, yes students, when I take here minus, students, easily you can see 0 will give you 0 again, so no change here. So when I put here x is equal to 1, this term is 0. When I put x is equal to 0, this term is 0 only, so I have taken 0. Now in this term I am going to take x is equal to 1, this is sine inverse 1, and then I will take sine inverse 0. So now sine inverse 0 is 0, so I will put directly 0. So sine inverse 1, yes students, what is sine inverse 1? It is pi by 2. So therefore the answer is pi by 2 into this 0 is gone, 1 upon 2 sine inverse, you are going to get 1, which is equal to 1, this is, so pi by 2 into 1 upon 2 into pi by 2, which is equal to pi square divided by 8. This is the answer, students. So you can see how the example is given and how we have to modify and write it. Okay students, immediately we'll go to the next example. Quickly write down the next example, example number 3. So now you can see, students, this is evaluating the integration 1 minus 1 to 1, integration 0 to z, integration x minus z. I was discussing that some problems they will interchange x, y, z. So now you can see this is x, y and z they have given. So every time whenever they give this type of form, students, please see that you have to rewrite the question. Okay, so I will take integration I is equal to minus 1 to 1, integration 0 to z, integration x minus z, x plus z, x plus y plus z. Now when you are going to integrate, please remember in this first integration x plus z, what is missing? Can you tell me? There are only three variable, function of three variable x, y, z. If x, y is there, what is missing? Y is missing. So definitely this is going to become y. So y is gone. Next, x and z is there. Please remember here, what is missing? X is missing. So this is x. And here, last term, y and x is over. Last term is going to give you z. So means this is term of y, this is term of x, and this is term of z. Therefore, I have to integrate first dy, then dx, and then dz. This is the trick you have to remember. This is very, very important. Such type are likely to come in the examination point of view. Keep on practicing such type of example, students. Definitely you will get the good marks. Okay, so all the best. Practice the example, students. So integrate this now. I will take one by one, -1 to 1, integration 0 to z. Okay, so here please remember I am going to integrate with respect to y. Y is variable, then automatically x and z will become constant. Okay, so x is constant now. I'm going to integrate this now. X, y plus y is our integration, so y is variable, y square upon 2 is the integration, plus here again z is constant, so I'm going to in the limit x minus z, x plus z. What is the meaning? Dx and dz. Y we have done, so dx and dz. Okay, so immediately write down quickly. Substitute the values one by one wherever there is the possibilities are there. So integration -1 to 1, integration 0 to z. Yes, substitute wherever y is there, put upper limit x plus z and then x1. So first I will take in this term, x is constant, so only I'm going to substitute y value. This will give you x plus z minus x minus z. Lower bound and upper bound I have substituted here. I will get this. Then this closes, plus 1 upon 2 is constant in this. Okay, students, 1 upon 2. Now you can see y square is there, so I just take this as x plus z square minus x minus z the whole square. So this is, I have substituted the upper limit and lower limit. Similarly, next, plus, I'll continue this side, plus z is there, so I'll just substitute x plus z minus x minus z. So this completes our integration. So this is our dx dz. This is lengthy, but don't get confused. Open all the brackets, friends. I'm going to open all the brackets and I'm going to substitute the value of a plus b the whole square and a minus b the whole square. Please remember a plus b the whole square formula, a square plus b square plus 2ab, and a minus b the formula I'm going to substitute in this. So therefore this is going to become a square plus b square minus 2ab. Is it clear? So these are the very simple formulas we are going to use. Okay, one by one we'll simplify this. This is equal to integral -1 to 1, integral 0 to 2. Is it clear? So x is there outside. I will open the brackets inside. So this is x plus z minus x minus into minus plus z you will get. Then plus 1 upon 2. Okay, so I'm going to use the formulas. So this will give you x square plus z square plus 2xz minus x square z square plus x square plus z square, x square minus z square minus z square plus 2xz minus into minus will be there. Okay, so then plus continue our integration, x plus z minus x plus z. So what I have done here, friends, I have just taken the brackets, open the brackets. So now you can see here, friends, minus x plus x will get cancel, minus plus x square z square minus minus will get cancelled. Here also x plus x minus x will get cancelled. So what is remaining here, friends? Yes, so I will again -1 to 1, integration 0 to 2. Okay, so here what is remaining? X is there, z plus z is going to give you 2z, then plus 1 upon 2. Okay, here you can see plus 2zx plus 2zx will give you 4xz, then plus z into z again, this is 2z. So this will give you dx dz. This is z, dx dz is there. Okay, now we'll simplify this one. Integration -1 to 1, integration 0 to z. So just simplify, 2xz you will get, here 2 1 2 2 will get cancelled. So this is again plus 2xz plus this is going to give you 2z square dx dz. z students. Okay, now again this you can see 2x z plus 2x z will give you integration minus 1 to 1 integration 0 to z 4x z plus 2 z square dx dz students. Okay, so next again we'll continue. This is equal to now integration minus 1 to 1 integration 0 to z 4xz plus 2 z square dx dz you are getting. Okay, so now here we can see we just simplify this. Sorry for the disturbance. Okay, so I'm going to simplify here students. My pen is not writing properly. Okay, so this is equal to now I'm going to integrate with respect to x. So therefore this will give you integration minus 1 to 1. Okay, 4z is constant, only x I'm going to integrate. So 4z as it is, no change in 4z. Only I'm going to integrate with x. So this is equal to x square upon 2. Is it clear students? So now you can see this is plus 2. Here x is not there, so therefore x square z square x you will get the limit 0 to z. This is dz. So we are going to substitute here y values we are going to substitute in this ones. So please immediately substitute the y value. Y is equal to z. Okay, so now you can see this is equal to integration minus 1 to 1. This is 2 1s are 2 2s is there. This is 2. Now here you can see sorry x is equal to z is there. So already one z is there. So z square you will get. So this is z. This is going to become z square plus 2z square. This is going to give you z dz. So this is equal to integration minus 1 to 1. This will give you 2 z cube plus 2 z cube students. So this is dz. Okay, now 2 z cube plus 2 z cube will give you 4 z cube dz. Is it clear students? So therefore 4 is constant, so take it outside. 4 integration of z cube. Yes students, you will get z raised to 4 divided by 4 in the interval minus 1 to 1. Okay students, so now just simplify this. 4 and 4 will get cancelled. Now you substitute here 1, therefore you will get this z raised to 4. So 1 raised to 4 minus 1 raised to 4. Easily put in the calculator, you will get the answer 0. So this way you have to simplify the problem very easily. Is it clear students? So next we will continue with the next problem. Write down next example number 4. So please write down example number 4. Evaluate integral 0 to pi by 2 integral 0 to a sine theta integral 0 to a square minus r square upon a r into dr d theta dz. Yes students, now they have changed the variable. Instead of x and y they have given in this term. So now you have to identify which terms are there. So this is a function of r, theta and z. This is a function triple integration r, theta and z. Instead of x, y and z they have given the 3 variables in a different way. Okay, so we rewrite this again equation once again. So just see how we are going to rewrite. So I'll just take, let we rewrite this equation integral 0 to pi by 2 integral 0 to a sine theta integral 0 to a square minus r square upon a. So this also we have to simplify. So this is r. Now we can see what term should be taken first. Here we can see r, theta and z is there. R, theta and z is there. So first which you have to take. So here we can see r is there already. So you cannot take r. Is it clear? So then which will become the r? This is going to become r. So here this is going to become r. Then what is remaining next? Yes, next is z. So I will take z here, theta. Here you can see here theta is always taken it as angle pi by 2. So this is going to become theta, this is going to become r, and this is going to become z value. So first I have to take dz, then I have to take dr, and then last I have to take d theta. To take theta last is because of pi by 2. Pi by 2 is an angle, therefore I can take this theta is as angle, and angle you can see I can take this as pi by 2 radian. Okay, so I will first integrate with respect to z, then I will integrate with respect to r, and last I'm going to integrate with respect to theta. So one by one we are going to integrate. Okay students, so now immediately write down I is equal to integration theta 0 to pi by 2 integration r 0 to a sine theta. Now integration of r is become constant when we take this as z value. So this is r into z. Okay, so this is from 0 to a square minus r square upon e. This is upper limit and lower limit ones. Okay, then this is dr d theta. Okay, so just substitute the upper limit. So I is equal to, yes students, you will get I is equal to integral 0 to pi by 2 and integral 0 to a sine theta. So this is r, just substitute upper limit a square minus r square upon a minus 0 you will get, and this is dr d theta. Minus 0 you can leave it, so only r a square minus r square will remain divided by a. A is constant, so I will just take it outside friends. 1 upon a I will just take it outside, therefore I is equal to 1 upon a, and r I will multiply inside this bracket. So this is integration 0 to pi by 2 integration 0 to a sine theta. This is r a square minus r into r will become r cube, then this is going to give you dr and d theta. Is it clear students? Okay, so now I'm going to integrate with respect to r. This is going to become r and this is angle, so therefore I have taken this as theta. Okay students, 1 upon a integration 0 to pi by 2. So wherever r is there, I'm going to integrate. Here r is variable, a square is constant, so integration of r dr will give you r square upon 2, and integration of r cube dr will give you r raised to 4 upon 4. So therefore this will just substitute here, r square upon 2 minus r raised to 4 upon 4 in the limits 0 to a sine theta. So this is what we have to substitute the value of r is equal to 0 and a sine theta. So just substitute. Okay, this is going to become 1 upon a as it is, no change. 0 to pi by 2 as it is, no change. So here a square remains as it is, a square upon 2 is constant, so just put r is equal to a sine theta. Yes, here students, this is square, and you can see 0 is 0, r square 0 is 0, so I don't take here 0 now. Minus here 1 upon 4 is constant. So now I'm substituting upper limit and lower limit in this. So this is going to give you a sine theta raised to 4. Again minus 0 is 0, so this is our simplification. Is it clear? So now simplify this further. This will give you equal to 1 upon a integral 0 to pi by 2. Here you can see a square is there, again square is there, so I can just take this as a raised to 4 upon 2. Then this is sine square theta minus 1 upon 4. Here again you can see a raised to 4 is there, so I'll just take a raised to 4 sine raised to 4 theta d theta. So here because if 4 raised to 4 is there, so I can take 4 for this and raised to 4 for this one. So okay, so now I have to remember this one formula using integration 0 to pi by 2 sine raised to n theta d theta is equal to n minus 1 upon n into n minus 3 upon n minus 2 dot 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 1 upon 2 into pi by 2. How to utilize this formula I will tell you. If you take square and cube, you will get 0 to pi by 2 if you have sin square theta. See, please remember, if n is even, then only we can apply this formula. So if n is even, yes, n is even, yes, square, n is even only, n is 2. So this is d theta is equal to, just put 2 here. So this is 1 and this is 2. So 1 upon 2 into pi by 2. And see, integration 0 to pi by 2 sine raised to 4 theta into d theta. So 4 you put. So you can see here, when you put 4, 4 minus 3 is 1, 4 minus 2 is 2. So here 4 minus 1 is 3, and here 4 minus 4 is there. So n minus 1 upon n. So this is give you 3 upon 4 into 1 upon 2 into last term will be always pi by 2. So these two values you substitute. Therefore, you will get here from using all these formulas, practice these formulas, you will get the integration 1 upon a raised to 4 upon 2, 1 upon 2 pi by 2 minus a raised to 4 upon 4, 3 upon 2 into 1 upon 2 into pi upon 2. So what I have done here, students, only I have substituted this value and this one in the formula. If you simplify this, a raised to 4 upon 2, here you can see a raised to 4 upon 4 is there. When you simplify, take out all the common parts. So you can see this is equal to a raised to 4 is there already. I have taken a raised to 4 outside. You see here a raised to 4 I have taken outside. Divided by a is already there. I will keep it as it is, no change. So this is give you pi upon 2 into 2 into 2, 8. Minus a square is outside, so 4 is there, divided by 4 is there. So this is 3 into 1 into pi is 3 pi, divided by 4 into 2, 8, 8 into 2, 16, 16 into 2, sorry, this is 4, let's substitute. So 4 into 4, 16, 16 into 2, 32, 32 into 2, 64. So when you simplify this, you must get 5 pi a cube divided by 64. This is the answer. So this way you have to simplify many more examples of double integration and triple integration especially. So another last example we will take quickly. So we'll take example number 5. Very, very simple. Evaluate integral 0 to 4, integration 0 to 2 root 7, 2 root z, sorry. This is integration 0 to square root of 4z minus x square dy dx and dz. Very, very simple problem you can see here, students. So we'll take let this integration be I is equal to, okay, so again you can see, yes friends, you have to rearrange. So now this is 0 to 4 as it is, this is 0 to 2 root z, and this is integration 0 to 4z minus x square. Now this is nothing is there, means consider this as one number. Okay, so what you are going to arrange, so you can see here this is a function of x, y and z, so two variables. So you can, in the first integration you can see at the upper limit x and z is there, so what is missing, y is missing, so this is y value. After y, x and y is remaining, x and z is remaining. If z is there, means this is x and this is z value, means you have to arrange this equation in terms of x, y and z. Then you can simplify this very easily. But whatever integration we have done here, you can see, students, in such type of examples, so already they have arranged. So first I'm going to take dy, then I'm going to take dx, then I'm going to integrate dz. So first I'm going to integrate with respect to y, then I'm going to integrate with respect to x, and lastly I'm going to integrate with respect to z. Okay, let us start integrating. Integration 0 to 4, integration 0 to 2 root z. Okay, integration of 1 with respect to y will give you y, upper limit and lower limit 0 to 4z minus x square dx dz. Okay, so substitute integration 0 to 4, integration 0 to 2 root z. So I'm just substituting the value 4z minus x square dx dz. Please remember, we don't have any formula for square root of 4z. So therefore I'm going to take this 4z, I will take for our convenient a square. So please remember the formula, students. Whenever you get the integration square root of a square minus x square, so already I have given the formula in previously. So again I'm going to take this x square root a square minus x square upon 2 plus a square upon 2 sine inverse x by a. So this value you substitute, therefore the integration will look like this. This is in integration 0 to 4, integration 0 to 2z, right? I have substituted this as a square only, so this is square root of a square minus x square. Am I right? I have just substituted, this is dx and dz. Is it clear, students? So please see here, I have taken 4z as a square, so this is the formula, just substitute the value now. Integration 0 to 4, integration of this is going to give you x square root of a square minus x square upon 2 plus a square upon 2 sine inverse x by a in the limit 0 to 2 root z dz. Wherever x is there, you have to put 2 z upper limit, and wherever z, you put 0. Okay, so first you put in the first term, you put x is equal to 2 root z, but please remember a square we have taken 4z, so you can see what will be a is nothing but square root of 4z, which is equal to square root of 4 into square root of z, or we say it as 2 root z, or simply say 2 root z is equal to a. So this value is going to become a. So I'm going to put 2 root z as x a. So x is a. So I have converted a square is equal to 4z. So this value is going to become a. So just for your understanding, I'm writing now x is equal to is the upper limit, x is equal to 0 is the lower limit. Here next you substitute x is equal to a upper limit, x is equal to 0 lower limit. Okay, one by one we simplify these ones. Integration 0 to 4 is there. So next term. Here you can see when I put a in this, students, a square minus a square is 0. So this a square is 0 when I put upper limit. Okay, when x is 0, this is 0, this term is 0, so 0 into anything 0. So when you put upper limit and lower limit for this, both the terms is getting 0. So I will put 0. Okay, plus a square upon 2 constant. I will take this term. Now first I will take a, so this is going to become sine inverse a upon a. First I will take x is equal to minus sine inverse 0. Then this will be z. So now you can see sine inverse a divided by a is sine inverse 1. Any doubts, friends? This is nothing but pi by 2. Okay, so this is pi by 2. I will take it outside. Whatever constant terms are there, please take it outside, students. And then we are going to integrate with respect to z. Is it clear, students? Now a square. What is a square, students? Please remember, a square is nothing but 4z. I will substitute a square is equal to 4z. So therefore, this will give you pi by 2 outside. Integration 0 to 4 a square by 2 dz is there. Put a square is equal to 4z. So this is going to become pi by 2 integration 0 to 4z divided by 2 dz. So now we can see as students 2 1s are 2, 2 2s are 4, 2 1s are 2, 2 1s are 2. So this is give you pi integration 0 to 4 z dz, which is equal to pi integration of z is nothing but z square by 2 in the limit 0 to 4, which will give you pi. And now I'm going to substitute z is equal to 4 and z is equal to 0. So first this is going to become 4 square upon 2 minus 0, And when you simplify this, 4 square is 16, 16 divided by 2 is 8, so the answer is 8. This is how we have to calculate this, students. Thank you so much for watching the video. Please see that when you study triple integration, you should also understand double integration. Previous lecture I have discussed the double integration, this triple integration. If you like the video, please subscribe and press the bell button, and also circulate with your friends. And very, very important, please like the video, students. Thank you so much. We'll continue in the next class, students. If you like and students demand, I will again